Hi everyone, today we are going to study new module, logical design and implementation. In the previous module, we spent a lot of time for studying entity relationship diagramming or conceptual modeling. Now it's time to convert this conceptual model ERD into logical model. Logical model is basically creatable statements. But before we directly move on this next step, logical design, I want to add two more topics that is about normalization. So what is this normalization is, I'm going to explain in detail shortly, but basically this is kind of a checkpoint how good your conceptual model is, whether you are ready to move on to logical modeling. So since it's kind of in the middle between conceptual model and logical model, some people say normalization is part of conceptual modeling, the very end point of conceptual modeling. Some people say normalization is just the starting point of logical design, the next step. But I include this normalization as a topic part of logical design. So let's talk about normalization in the following two topics, topic 1 and topic 2. In topic 1, I will explain all the concepts and I will use one example. In topic 2, we will apply what we have learned in topic 1 using a little bit different examples. So what is normalization? The concept itself is very similar to ER diagram. So how did we develop ER diagram? What was the starting point motivations? If you remember, we decided to apply some database design techniques, since if you just start with random data model, it may have a lot of problems like redundancies and anomalies. You may remember there are several data anomalies regarding to insertion and update and the delete anomaly. I will not repeat this, but with those kind of anomalies, we started to make several entities, and we developed an entity relationship model. And by doing this, we minimize redundancies and the problems with the database like data anomalies. So by developing ERD, actually we could make a better database design. Normalization, why we need it, actually it's the same purpose. By applying this normalization technique, we can make a better database. So normalization itself is kind of a series of stages called normal forms. What this means is you will start with random database, and then if you apply some step described in normalization, you will get the first output is called the first normal form. Using this first normal form, you may apply some more normalization process. Then you will get a little bit better. Better means better than first normal form. That is called the second normal form. Now, using second normal form, if you further apply normalization process, what you can get even better normal form. That is called the third normal form. So by moving on step by step, you can get better normal form. So let's talk about a little bit more about normalization. As you move on from first to second and the third normal form, although we don't know how each normal form looks like at this moment, you know that it is better than previous normal form. So for most business database design, we want to step by step move on, and we may get third normal form. So you may ask whether third normal form is then the perfect one. No, actually there are further steps. From third normal form, you can make a fourth normal form, and there is a fifth normal form as well. However, in general, for business database design, third normal form is pretty sufficient, good enough. So particularly in this lecture, we are going to stop when we obtain third normal form. So you don't have to worry about fourth or fifth normal form, although they exist. As we are getting higher normal form, In general, it's better from database designer's perspective because we have less redundancies and anomalies. So if you get first normal form and the second normal form and the third normal form, sometimes you may want to intentionally go back to second normal form or intentionally go back to first normal form. So why we need it? Because from database designer's perspective, it's always good to remove redundancies. But from programming perspective, sometimes when you have a lot of scattered tables, it takes longer time to process it. For example, let's say there is a customer table and there is a sales table. If you combine customers' sales information all together in one table, you may find a lot of redundancies. So we may want to break it, customer and sales, and we can just rewrite this with primary key and foreign key. If you have these two tables, it is better in terms of database design. However, when you process it, for example, let's list customers' sales orders in one screen. If you read these two tables separately and rewrite them together, it's costly in terms of processing it. It takes longer time. When you sacrifice this redundancy, it means when you make just one big table that combine customer table and the sales table together, although you may find some redundancies, if you read just one table instantly, your program itself could be faster. When you complete third normal form, to improve system's performance or the speed of a program, you may want to go back to a little bit more redundant data set. And this makes your system a little bit faster. So as you can see here, denormalization is not always bad, but it says that intentionally we can denormalize database. By doing this, actually price paid for increased performance. That means faster programs, although there could be some redundancies. Now, so one small business case. Using this example, you may better understand how you can normalize some other general database cases and scenarios as well. So there is a company, and this company manages several building projects. So each project has its own project number, name, and employees are assigned to it. But each employee has an employee number, name, and also job classification. Job classification means there are some certain jobs like engineer, computer technicians, some specialties. The company charges its client by billing the hours spent on each contract. And the hourly billing rate is dependent on the employee's position. Employee's position means what? Here, job specifications. Each job specification, the rate could be different. Periodically, a report is generated that contains the information displayed in the following table. So what is the table? Let me show you the table and you may better understand it. So here is a sample report layout. And in each project, Evergreen, Amber Wave, Rolling Tide, we have several employees. So each employee, we have information here given here. So employee has a name, and the employee has a job specification, and the employee, there is hourly charge. That means give 1 hour, how much we charge. And this is the hours billed. That means the specific employee, for example, June, how many hours? 23.8 hours she's working for which project? Evergreen project. So here's the total charge. Total charge is charge hour multiplied by hours billed. But if you consider this data as just one big table like given here, we may have a lot of problems and redundancies we described even in the previous module. For example, in this case, for one project we have many employees, but let's look at employee, for example, let's say what is good, Alice. If you have, let me highlight it. So here, if you look at this Alice, Alice is working evergreen project, but at the same time, this same employee 1 of 5, Alice is working for rolling tide project as well. So if you look at Alice's information, here is the name, and the database designer is her job specification, and the charge hour 1 of 5, 1 of 5. And this kind of information is repeating because in two different projects we have same employee, and this employee information is repeating, or it shows some redundancies. So we can see there are some problems with the redundancies. Not only this, if you look at some other informations like job specification, for example, let's say database designers, how much we pay 1 of 5. But if you look at John, who is a database designer as well, and we already know we need to pay 1 of 5, but this is a part of John employee's information. So actually this $1 of $5 for database designer, regardless of the employee, we apply the same rate. But since two employees have the same job specification, the information about this database designer is also repeating. So why we have this kind of problems? We mentioned this previously in the conceptual modeling using the concept of anomalies. The problem is we combine several different facts altogether. For example, project information is separate from employee information, and employee information is separate from job information, something like that. Since we combine all information together in one big table, we have those problems. Okay, so now let's start normalization to remove the redundancy and the anomalies that we addressed before. So before we start actual normalization, we first study the concept called functional dependency. Functional dependency is not very difficult. It's very similar to how primary key works in ER modeling. So to better understand the functional dependency, let's start with reviewing about the keys. So in ER modeling, we have two keys, primary key and foreign key. So it's given here. So primary key is a unique identifier. So as an example, in a student's table, student's ID is primary key because ID number uniquely identify the student's information. So for example, let's say student's ID is 1001. We know that what's the student's name and what's the student's address and something like that. In other words, given one value of a primary key, we can determine one name, we can determine one address. So primary keys work as a unique identifier that can be used to retrieve one value for other attributes. Note that primary key can be composite, right? So it doesn't have to be one attribute or one column. For example, if it is info 386 section 1 class, to specify or to uniquely identify one class, not only course number, we need to combine section number as well. So there could be multiple attributes used together to make a primary key. In that case, we call this as a composite primary key. In general, composite key means more than one attributes are used for making a key. In addition to the definition of a primary key, let me just introduce two more key concepts. The second one is candidate key. Candidate key means an attribute that could be a primary key. What that means is, suppose there is an employee table, and in employee table, let's say we have employee number, and at the same time we have employees SSN numbers. Then we may choose either employee number or employee SSN as a primary key. So suppose we chose employee number as the PK. Then actually the other attribute, although it could be SSN could be primary key, we did not use this as a primary key. Then how do we name this? Both of them, employee number and SSN, both of them are candidate key. So we have two candidate keys in this example. But we chose the employee number as a primary key, then this is a primary key. But what is employee SSN? It was not chosen as the primary key, but it was a candidate key. In that case, we name this as an alternate key. Alternate key means a candidate key that is not selected as a primary key. So now you understand what primary key means and what is candidate key, what alternate key means. So we briefly review about keys. Now I will just skip foreign key because we talked about foreign key a lot of times in ER modeling. That is referencing the other entity's primary key, so we can keep the relationship, right? Okay, so why we talked about those keys in this normalization? Because that is very similar to the concept of functional dependency. Okay, so now we are ready to talk about functional dependency. What this functional dependency means? It's a kind of relationship between two attributes. So let's say there is attribute A, and the notation is just arrow, and then there is attribute B. So what this arrow functional dependency means, here the definition is functional dependency simply refers to relationships between not entities but attributes. In ER modeling, actually, we are talking about entity and how they are related like this with close fit. In that case, the relationship is between entities. But in this case, functional dependency, we are talking about one attribute and the other attributes. So A to B, this kind of functional dependency means the attribute B is functionally dependent on A. And this means when we choose one value of A, if you can determine only one value of B, we can say there is a functional dependency. So to better understand the functional dependency, let me use the example, same example we mentioned before. So in this sample report layout, which column, which attribute determine what the other attribute or columns? So determination means when I give you one value, you should be able to choose just one value of the other. So let's say there is a project number. So if I give you project number 15, what you can determine? Can you determine project name? Yes. What is the value of project name? Evergreen. Can you choose more than one value, like evergreen and some other names? No. There is only one name you can choose if I give you one project number. So here, if I give you project number, for example, 15, since I can determine the name as evergreen, so therefore, this project number determine project name. So here on the right side, you can say project, it is number, and it is name. So you can say project number attribute determines project name attribute, or you can say there is a functional dependency from project number to project name. It's not that difficult, right? How about the other example about employee? So if I know employee number, what I can determine? For example, if I know employee number is 101, we know that employee name, there is only one employee named John News. And can we determine job class? Yeah, actually we can determine job class as well because there is only one job for each employee. Since we know job, can you determine how much you pay? Yes, $105. How about hours billed? Can you determine it? No, you cannot. Why? Because, for example, same employee 101, John, News here, still same job class we can determine and the charge hour we can determine, but we have a different value here. So when I give you 101 employee number, there are more than one value, like a 15.4 and a 15.6.3, two values are available. So you cannot just choose one value for hours billed. Yes, definitely, it makes sense. Why? Because same employees working for different projects, and for each project there are different hours John has worked. So we have different hours billed. So from that point of view, how can we determine hours billed then? Actually, not only employee number 101, what you have to know. If you have information of a project, for example, 15, 25 for star flight project, now what you can determine, oh, there is hours billed, 6.3 hours. So sometimes to determine one attribute, like hours billed here, what do you need? Not only just one attribute, actually you need project information plus employee number together, then you can determine one values. Okay, let me summarize what we have discussed here using these examples. The one example I showed you is project number determine project name, because if I give you one value of a project number, you can determine just one value of a project name. Then we say that project number on the left side functionally determines right side project name. Or you can say that project number on the left side is determinant attribute, and the right side project name is called dependent attribute. So determinant attribute functionally determines dependent attribute, and in this case project number functionally determines project name. Also in the previous example, I explained the hours each employee worked for each project. You cannot just use employee number, but you have to combine employee number and project number together. So in that case, actually we can explain full or partial functional dependencies. So let me talk about this using the examples of project number and employee number. Suppose we have here project number and employee number together as a determinant. Actually, I use this example because these two are kind of a composite primary key that I'm going to mention later. Suppose we have project number and employee number together on the left side as a determinant. Then on the right side, suppose we have employee name. In that case, if you consider this project number and employee number together, do you really need both of them to determine employee name? Actually, it's not. Why? Because just using one employee number, what you can determine employee name. And project number is there, but it's not necessary to determine this project name. Definitely, if we combine both together, these two can determine employee name, but the key here is this project number is not necessary. In that case, when there are two attributes on the left side as determinant, if you use only part of this, for example, employee number as the determinant of employee name, we say there is a partial dependency from employee number to employee name. But this is different from the hours, working hours case. If it's working hours case, let's say there is again project number and employee number together on the left side, then can we determine this working hours using only employee number? No. Why? As I told you, John, the same guy can work for two different projects, and in that case, hours are different. So employee number cannot determine working hours because we don't know which project he has been working. How about project number itself? So in one project, there are many employees. So project number, if I give you one number, depending on which employee, the hours are different, so we cannot determine. So employee number by itself cannot determine hours. Project number cannot determine hours either. Only when you can determine working hours, when you know both of them. So when you combine project number and the employee number together, now what you can do, you can determine hours. So can you see the difference here? Employee name can be determined just a part of this two attribute employee number. So it is called what? Partial dependency. But if we look at the second example, only when we know project number and the employee number together, we can determine hours. Then it is called the full functional dependency. Based on this example, let's read the formal definition of partial and full functional dependency one more time. If attribute C is functionally dependent on a composite key means what? Project number and employee number. So in this case, A and B. A is project number, B is employee number, but not on any subset of that composite key. That means just the project number or just the employee number, we cannot determine hours. We need both of them, complete, composite key set, these two attributes, then we can determine these hours. Then this attribute C, hour, is fully functionally dependent on A and B. So here, as a notation, A means project number, B means employee number. When we have both, we can determine C. But when we just look at A, we cannot determine C. When look at just B, we cannot determine C. Then this kind of dependency is called what? Full functional dependency. So as an example here, I showed you project number. There are many employees, so we cannot determine hours. Even one employee can work for many projects, so we cannot determine hours. But only when we know project and employee together, just one project and one employee, we can determine hours. So it is a good example of what? Full functional dependency. And when we determine one attribute with just a part of your composite primary key, it is called what? Partial functional dependencies. So far in this example, we talked about functional dependency, and further we understand what is partial and the full functional dependency. One more thing that I wanna talk about functional dependency is a special dependency called the transitive dependency. So let me write down here, transitive dependency. So what this transitive dependency means, a good example is given here. Let's say employee number 103 is given, then what you can determine, as I told you, we know there is one specific name, and even we know what is his or her job class. And if we know job class, what we can determine? We know how much we pay. So here, given employee number, we can determine name, job class, and even we know how much we need to pay. But behind this functional dependency, if you carefully observe this, you can easily figure it out. Oh, there is a separate functional dependency from job class to charge hours separately. So what this means, if I know electric engineer is job class, we know we have to pay $85. So for example, here, regardless of the employee information, if we choose another electrician, so we may know that the pay rate is $85. So let me look at some other examples. For example, system analyst, how much we pay? 96.75. If you find another system analyst, although it's a different employee, we know we pay this 96.75. So job class actually determine what? Charge hours. So if we look at the information here, yes, at the beginning I told you employee number can determine this charge hour. However, why we can determine, if you think about that, given one employee, we have a job class. And this job class sequentially determine charge hour. Therefore, one employee, we can determine this charge hour. So in summary, what does that mean? Here we have a functional dependency. In summary, employee number can determine charge hour. However, the reason why we can determine charge hour is employee number determined here job class. So job class is given, then we can determine charge hours. So behind this first functional dependency shown here, we have a kind of sequential link from employee number to job class to charge hour. So formally, if I use notations like A, B, C alphabet, so here let's say A determines C because A determines B and B determines C. In that case, this linking part, B to C functional dependency, it is called transitive dependency. So in this case, what is a transitive dependency in this example? The connecting part is what? Here. So what is that? Job class to charge hour, that is our connecting dependency. So it is called transitive dependency. So we could find one transitive dependency in these examples. Okay, that's all about functional dependencies. We did not start normalization yet, but based on these functional dependencies, we can make a normal form, like a first normal form, second normal form, and the third normal form. So in the next video, I will fully explain how we can develop these normal forms following the normalization process.